Okay, so application of potentiometer last time. Quick revision part 2. Yesterday we discussed first part of current electricity. Now the remaining part, let us see. Potentiometer, use of potentiometer. As you know, the potentiometer is a 600 to 1000 centimeter length wire. So its potential drop is considered. So what is the principle of potentiometer? First of all, you should know the connection of potentiometer, right? So you should know the connection. This is rheostat. Okay, the potentiometer circuit has a rheostat which changes the resistance of the wire. Okay, and a battery potentiometer circuit is connected a source, that is the potentiometer battery. Okay, one key and one rheostat, changeable resistance, which is connected like this. Remind it, the positive point is connected to this point. If this is A point, this is B point, and this is potentiometer. Potentiometer is nothing but a wooden board. Some wires are connected like this. In a wooden board, some length of the wires are connected like this. Okay, so it consists of one scale, two scales here. Okay, two scales are there. So this is potentiometer one. So this point is A, suppose A point, and this point is B point. A point, B point. Okay, this is wooden board. So you have to connect a battery positive to B point. That is through the rheostat. So rheostat changes the current, that is changing resistance. Rheostat to hold variable resistor, it changes resistance periodically. That is, when you want high current, you change the resistance to low value. Okay, so this battery will send current in the potentiometer wires. Nothing, just what is the principle? The principle of potentiometer is that the voltage drop is directly proportional to the length of the wire. Potentiometer principle to hold voltage drop across the wire is directly proportional to the length of the wire. So by connecting a galvanometer, you have to find out the length in a balanced condition. Okay, so one application, as we know, to compare the EMFs of two cells. Okay, so how you have to connect? You have to connect these two cells like this. Suppose epsilon1, epsilon2. This has EMF epsilon1 and this cell has epsilon2. So you have to find out epsilon1 by epsilon2. Okay, what is the ratio of the EMFs? So next step, what do you have to do? So you have to connect this in a two-way key. So in the common key, you have to connect a galvanometer, right? You have to connect a galvanometer, right? So this is a common key, two gaps, দুটা gap থাকে. এক নম্বৰ gapটো যদি তুমি পুৰাই দিয়া, কিবা এটা সুইচ এটা আছে পুৰাই দিব লাগে, এক নম্বৰ gapটো যদি কানেক্ট কৰি দিয়া এইটো আহি যাব. ওকে, ফাৰ্স্ট এইটো আহিব. ফাৰ্স্টটো আহিলে তাৰ কাৰণে তুমি ব্যালেন্স লেংথ উলিয়াই লোৱা. এল ফাৰ্স্টটো কাৰণে ধৰি লোৱা ব্যালেন্স লেংথ L1, সেকেন্ডটো কাৰণে ব্যালেন্স লেংথ ঠিক তেনেকৈ সেকেন্ডটো কাৰণে উলিয়াবলৈ হলে এইটো অফ কৰিব লাগিব, এইটো কানেক্ট কৰিব লাগিব. ঠিক আছে, সেকেন্ডটো কাৰণে তুমি ব্যালেন্স লেংথ উলিয়াই লোৱা. So according to this principle, you get this principle. So there will be a constant in both cases. The constant is same. Divide koi dia to get rid. So you will get This is potentiometer. Way application of potentiometer. First application, how to uh, how to determine the ratios of two EMFs. Okay, this is one way. And secondly, you have to. Secondly, you have second application. You have to remove this. Okay, this is first application to compare the EMFs of two cells. Second application is another very important to find R. What is R? R is the internal resistance of a cell. R of a cell. This is another application. So for this, what you have to do? Same principle. Principle is same. Okay. Principle is same. Epsilon, it is EMF or potential drop, is directly proportional to the length of the conductor. So how you will find the length? You mean length can you by observing the galvanometer deflection. If galvanometer gives zero deflection, then length, the particular length, you will get the balance point. Okay. So, but circuit diagram you have to change. Circuit diagram to change. We have already discussed this. How will change the circuit diagram? So suppose this is your battery. Always remember the battery positive should be connected to this because you are connecting the potentiometer battery positive with this point. Okay, all positive points should be connected with B. This is one thing. So that current should pass through this way. Okay, this is one of the important point that you should connect all the positive points to point B. Next, what you have to do? So this is external resistance. Okay, so one key. This is key, and the galvanometer is here. Connection is here. Okay, this is, suppose E is the, we are writing epsilon. Epsilon is the EMF of this battery, right? Capital R is the resistance of external resistance, external resistor, and small r is the internal resistance of this cell. So your idea is to find out the internal resistance as we have discussed. Okay, so what you have to do, first of all, without connecting this resistance to this cell, this is a circuit to kami off kori lobo lagibo. A off koribole hole etu kami open koro, mane etu circuit ami dibo nalagibo, open circuit. Ephale current na jabo, ephale current na gole okol etu thakibo. Only for this EMF you have to find out the length. Okay, you have to find out the balance length. So suppose you got L. Okay, balance length L. You got L at some particular length L. Okay, at this length you got L is the balance length. For what? For without connecting R in the circuit. Without connecting R in the circuit. So R include nokorake tumi okol ER EMF to level tumi balance length to diala L tar pa etu ami principle pal. Next ahibo. Next ahibo. So you are getting this. Next, yak connect korilu. Connecting this, you are getting potential drop here, right? So you are getting potential drop. So for that, you have to take the terminal voltage V. Okay, not EMF. So initially, without current passing through it, you are getting the EMF. Okay, the potential drop is equal to the EMF. Etu connect nokora karone tumi etu pala. Connect korile mane yat voltage drop hobo across R. So voltage drop hobo V. Voltage drop across R, you will get some voltage drop for the current I. Efale current jabo. So in this way current will go. So voltage drop to karone tumi yat balance length power. So for dead balance line, suppose L2. Okay. Okay. So suppose V by dividing this equation number 1, equation number 2. Dividing 2 by 1, dividing 2 by 1, you will get V by epsilon is equal L2 by L1. Okay. This is one equation. Okay. This is one equation. You keep it aside. So next, what you have to see, you see that according to Ohm's law पर तुम्हें की पाबा V is equal IR, right? It is important to find internal resistance R. এটা পাহৰি থকা হয়, খুব পাহৰি থকা হয়, এখানে revision is compulsory. ঠিক আছে? So according to Ohm's law, you get this V is equal IR, right? Again, when current passes through the internal resistance R, so you have to consider total current and total resistance in the circuit. Okay. So according to Kirchhoff's rule, if you apply the current I passing through two resistors R and small r, then epsilon is the EMF. Then what you will get? You get that I, that is epsilon is equal. Okay, epsilon is equal. Then in that case you have to take the EMFs. Okay, epsilon is equal I capital R plus small r, because total resistance in the circuit, in this circuit, is capital R and small r. So you have to take this, right? So epsilon is equal, this is equation. This is equation number 4 and 5, right? So dividing 4 and 5, you will get these similar equations. Dividing 4 and 5, 4 divided by 5, what you will get? You will get V by epsilon is equal R by capital R plus R. So this is similar to this. Okay. So V by epsilon is equal this, and L2 by L1. Sorry, this is not L2. L2 by L1. Okay. L2 by L1. Right. So in place of V by epsilon, you can put L2 by L1. L2 by L1. Right. So you are in need of R. That is why let us take reciprocal of this. I mean, 3 4 divide kolu. 4 of the 3 divide kolu. I mean, it ulta palo. Now R plus R by R is equal L1 by L2. Yeah, ulta dile na kaho. R plus capital R plus small r to upolo logolo. Small r capital R. ठीक है सर? So here केते आपको capital R में divide कोई dim R by R1 plus capital small r by capital R is equal L1 by L2. So amak ki lage? We want small r. So from this expression you have to find out small r. So 1 to khifale loi jwa, 1 to khifale loi jwa, so -1, right? So now you are in need of small r. So small r will be what? Capital R L1 L2 -1. So R is known value. From here you can find out R. L1 is known value from the scale, you can find out the L1. L2 is known value from the scale, you can find out L2. So from this expression, putting the values of R, L1, L2, you can find out the value of small r. It is your second application. So I think this quick revision will help you, right? So these two are the most important applications of potentiometer. Many problems you will find to solve with this formula. So if you have conception, then you can do it again and again. Then you can remember this formula and how to find at once one time single attempt you cannot find it. But if you do 2 or 3 times, then you can be able to find the internal resistance very easily. Okay. Next topic will be what? Oersted experiment and then Biot-Savart's law. Next topic is Oersted experiment and which leads to Biot-Savart's law. Okay, this is quick division. That is why I am not explaining all the things point to point, right? So as you know, Orsted, what experiment Orsted has done? Orsted just studied that when current passes through uh, a coil above above a magnetic needle, this is North Pole. When current passes through just above the magnetic needle, then the magnetic needle deflects. That is, if North Pole is there, then North Pole will be just deflect as soon as current passes through. When switch is off, again it deflects in the opposite direction, right? It means that Oersted experiment explains that there is a close relation between electric field as well as magnetic field. It was the first experiment. And after that, when current passes through a conductor, it produces magnetic field, and the value of magnetic field was calculated by Biot and Sebert separately. And after then, it was calculated by Ampere. Okay. So the value, that is the value of magnetic field, as we have discussed, that when current passes through a conductor, it produces magnetic field, but Oersted unable to find a magnetic field, value of magnetic field. The two scientists came, they calculated with some experiment, they were able to calculate the magnetic field value. So to find the Biot-Savart's law, as we discussed in earlier lectures, if suppose one length, experimental length dl is taken, current I is passing, and the center of the elementary length dl is taken as O, okay, and point is suppose from the point O, P is the particular point where magnetic field is to be determined, okay. So how they determine the magnetic field? If magnetic field is considered at this point B, then the magnetic field dB, okay, and the magnitude of magnetic field is directly proportional to current, directly proportional to the elementary length, and directly proportional to what? To the orientation, if this angle is theta, okay, sine of theta. So all these three factors, the magnetic field value depends directly, but one factor is there, which is radius. That is not radius, position vector from the point O to P. G2 pointer to me magnetic field uliaba, hey pointer like the distance is the whole R. Okay, ইয়ার উপর depend করব. So কেনেকে depend করব? That inversely proportional. So তুমি যিমানে দূৰলৈ লৈ যাবা magnetic field to কমি কমি গৈ থাকিব নহয় জানো যিমানে ওচৰলৈ আনিবা সিমানে magnetic field to বাঢ়িব so distance to বাঢ়িলে magnetic field কমে distance to কমিলে magnetic field বাঢ়ে so that is inversely proportional কিন্তু এটো square up so if you combine all these things then you can easily remember the Biot-Savart's law how so dV so you will be in need of one constant, that is k, suppose. So ideal sine theta r square, right? So k is proportionally constant mu naught by 4 pi, okay, which is equal to 10 to the power minus 7, okay. And now 9 into 10 to the power 9, sorry, and here you can convert this into vector form. How? As I discussed in about 4 pi. So how you will convert this into vector form? This is the scalar form of Biot-Savart's law. To find a vector form, what you have to do? So to find a vector form, mu naught by 4 pi, okay, mu naught by 4 pi I dl r. You have to multiply by r, both numerator and denominator, and it will be r cube. It will be r. Okay. So after then, you can put the vector dv mu naught by 4 pi and I dl cross r, because dl r sin theta indirectly is the magnitude of dl cross r vector. Okay, dl cross r vector can be written as dl r sin theta n cap. Okay, so this is the uh, representation of vector form of Biot-Savart's law, right? Now, next point we have discussed about applications. Applications. So it was the magnetic field this is the magnetic field for a particular elementary length. Total magnetic field level integrate it will small amount of magnetic field. Why dB? dB represents small amount. So if you integrate dB, you get B vector. If you integrate left hand side, you have to integrate right hand side also. So mu naught by 4 pi I dl cross r vector r cube. So this is the net magnetic field produced at P due to whole conductor. গোটেই ডালৰ কাৰণে উলিয়াবলৈ হ'লে তুমি ইন্টিগ্ৰেট কৰিব লাগিব. Okay. So next point is to application of Biot-Savart's law. After this application, so many applications are there. Applications of Biot-Savart's law. Okay. So any application, I mean, application. So one of the application is that to find magnetic field. If we remember one application, then we can find others also. So current is going, okay, dl, right? So the O at the center, it makes an angle 90 degree. This is O. If you are asked to find out magnetic field at the center, okay, at the center due to a circular loop, what we will do? So using the formula of magnetic field given by Biot-Savart's law, mu naught by 4 pi, okay, I dl sine of, in this case sine theta is 90 degree. Okay, what is theta? R square. Okay, if the radius is r, what is theta? Theta is nothing but the angle between r vector and dl vector. Okay, theta is the angle between r vector and dl vector. Here r is a vector, dl is a vector, current is flowing through this. So in this case, the radius always makes an angle 90 degree with the circumference. ব্যাসাৰ্ধডালে পৰিসীমাৰ লগত সদায় 90 ডিগ্ৰী কোণ কৰে, right? So if you put the value of sin 91, so what you will get? This. So therefore B is equal dB. Okay, mu naught by 4 pi, I is constant, come out. Okay, so r square is constant. For a circle, r is constant, so r square is constant. So only thing is that dl. So you have to indicate dl, right? Mu naught I 4 pi r square. What is the value of dl? Integration of dl. So integration of dl is integration of dl is L. Okay, that is integration of L is dl is L. So L has to be found. L is nothing but the total length. What is the total length? Total length is the twice pi r. It is upper limit is twice pi r. So integration of dl is the total length of this circumference. If r is the radius, then circumference will be twice pi. So in place of integration dl, you can write twice pi r, right? So after calculation, what you will get? Twice pi will be cancelled to r, mu naught I. Okay, so B is found like this, right? So this is the application, and for solenoid. After then, this is circular center. Okay, at the center we found it, and after then, what we found? One application is to find the magnetic field at the center. Another application is to, what was the another application? Magnetic field at a point on the axis. So let me have a quick look. On the axis means what? There is a coil. Okay, there is a coil. So this is the axis. From the center, this is the axis. So current is flowing in this direction. So suppose this is your length dl. Okay, so current is flowing through this, and the tangential direction gives the dl direction, dl vector. Okay, so you are going to find out magnetic field at point P. P is on the axis. P point to axis of what asset to move. So suppose this is this radius is a, and this length is x, and this is r. Okay, so this angle will be 90 degree. Mind it. This angle will be 90 degree. And as I told that the magnetic field produced here will be
Sir, video to roll.
So the magnetic field produced here dB is perpendicular to both R and DL. DL to port ase, R port perpendicular me akibo paro. So it will perpendicular hobo. So in this direction, one component will be dB. If I do component jabo hetu, that if phi will do dB cos phi, and this component is dB sin phi. dB cos phi, whatever dB cos phi hobo yat jodi ami long. So both dB cos phi will be cancelled. Okol etu thakibo, right? So dB is the magnetic field which is directing perpendicularly to radius. Okay, so it has two components. One component is dB cos phi is associated with phi angle, a2 direction. Another x direction. A direction thoka bilak cancel hobo karon efale eta olabo. Yat jodi ami eta component lo element lo etu enake cancel hobo. So a2 e thakibo. So tumi pabage ki tomak dorkar hobo dB net hobo dB cos dB sin phi. dB sin phi. So dB sin phi is the you are to integrate dB sin phi so that to get the total magnetic field produced by the whole conductor, right? So dB is what? dB is mu naught by 4 pi. Okay, mu naught by 4 pi. Okay, this angle is phi. This angle is phi. Okay, and mu naught by 4 pi I dl sin 90 degree is equal 0. Okay, dl আৰু r মাজৰ angle 0 1 হ'ব. Sin 90 is equal 1. So 1 হ'ব লাগিব. So r square means what? ইয়াৰ পৰা ইয়ালে r square and sin of phi. Okay, sin of phi. Integration into থাকিব এফালে. So is equal আমি কেনেকৈ কৰিছো mu naught by 4 pi I to বাহিৰলৈ আহিব. So r square bahira aibo kam nai r square thakibo ki dl integration of dl is equal kiman integration dl is equal ami kiman paisu etu dl to twice pi a gutetu ako sin phi is equal kiman hobo perpendicular by hypotenuse a by r, the value r. So a square mu naught I 4 pi r square r cube hobo 4 pi r cube twice pi cancel jabo na pi cancel jabo. So pi cancel ko thakibo 2 eta only 2 2 থাকে উপর a স্কয়ার সো mu naught I by 2 a square r keyboard হাতে আমি কি লিখব পার r square is equal a square plus x square so r cube is equal a square plus x square 3 by 2 right so a square plus x square 3 by 2 so finally we got the value as this b is equal this okay so we can now find out the magnetic field at point P on the axis of a circular coil due to current I passing through the conductor. So this is the expression. What is A? A is the radius. What is X? X is this. And what is I? I is the current. So from this expression you can find out the magnetic field at the center also. How? At the center, the P point will come to O. X will be 0. X to 0 হয়ে যাব x যদি 0 পুট কৰা তেলে a স্কয়ার থাকিব স্কয়ার স্কয়ার ক্যান্সেল যাব a কিউব হ'ব a কিউবত উপর a স্কয়ার আছে a স্কয়ারে a কিউব কাটাকাটি কৰিলে a হ'ব কলতলত সো সেন্টারত কি b is equal mu naught I a তলত a থাকিব twice a মানে আমি তাত r লিখিছিলো আগতে কোতে r কৰিছিলো so this is the magnetic field at the center ইয়াৰ পৰা magnetic field center পাব পাৰি okay very good